On one side, water stands level with the top of a vertical rectangular gate 1.2 meters wide and 1.8 meters high. Hinge at the bottom. On the other side, water stands 0.9 meter below the top. What horizontal force applied at the top of the gate is required to open it? And in the second situation, if the horizontal force is removed and there is no water on the other side, what uniform pressure in kilopascals must the other side be subjected to open the gate? So for the first situation, the water surface is flush with the top of the gate. So the location of the center of pressure for F1 is 2/3 of 1.8, 1.2, or 1/3 of 1.8, 0.6 meter from the bottom. Since on the other side, there is no water, or water stands 0.9 meter below the top, so that means this is also 0.9. So 2/3 of 0.9, 0.6, or 1/3 of 0.9, 0.3. So this is 0.3 meter. So from the hinge. So F1 is 9.81. So let's set up the equation. P should be, in this situation, P should be to the left so that the gate will open, because without P, it will definitely, F1 is greater in magnitude than F2. So to open the gate, it should be to the left to support F2. So summation moment about the hinge equals 0. P times 1.8 plus F2 times 0.3 equals F1 times 0.6. That's our working equation, where F2 is 9.81, 0.45, barred H is 0.45, half of 0.9. This is 0.9. The area is 1.2 by 0.9 only, because this is 0.9. So F2 is 4.768 kilonewtons. Then F1 is 9.81, barred H is 0.9, area 1.2 times 1.8. So F1 is equal to 19.07 kilonewtons. Substitute in our working equation. P times 1.8 plus 4.768 times 0.3 equals 19.07 times 0.6. So P is 5.562 kilonewtons. And in the second part, that's the figure. So F1 is still 0.6 meter from the bottom because it is unchanged. F2, because the other side is subjected to uniform pressure, is half of 1.8, so 0.9 meter from the bottom. Where F2 this time is equal to the volume of this pressure diagram, which is P times 1.8 times perpendicular to the board 1.2. So the working equation would be summation moment about the hinge equals 0 is F2 times 0.9 equals F1 times 0.6. Where F1 is still 19.07 kilonewtons, and F2 is pressure times 1.8 times 1.2, or volume of pressure diagram, P times 1.8, area of this rectangle, times width perpendicular to the board 1.2. So 2.16 P. Substitute in this equation. 2.16 P times 0.9 equals 19.07 times 0.6. So P is equal to 5.886 kilopascals. That's it.